Hi guys, welcome to lesson 4-7, where we're going to talk about congruence transformations. So there's probably going to be some new terms, new vocabulary in this lesson, maybe some things you haven't seen before. When we're done, we're going to be able to identify some of these types of transformations, including reflections, translations, and rotations. And then we're going to verify that if we have something that appears to be a reflection or a translation or a rotation, we're going to verify that it is in fact a congruence transformation using all of the skills that we've picked up so far in this chapter. All right, we've got some new vocabulary here that we got to look at, and including what is a transformation. Transformation is an operation that maps a geometric figure. Okay, that basically means we're making a copy of it, and a congruence transformation is a transformation that results in a congruent copy of the pre-image. Okay, there are certain types of transformations. For instance, we're going to look later in this course at dilations, okay, which are basically scaling up or scaling down an image, a figure, So that's a type of a transformation. But a congruence transformation results in a copy that's exactly the same size. It's congruent. Okay, so that's what we're going to be focusing on here in this lesson. When we do these transformations, the pre-image, pre meaning before, is the original figure. Okay, and the image is the copy. Okay, so the figure that is the copy of the pre-image. And you're going to see this term isometry. Okay, an isometry is just a synonym for a congruence transformation, or you may also see it referred to as a rigid transformation, because we're moving it around somewhere, but it's keeping its size and shape. It's staying rigid. Okay, and the three types of congruence transformations we're going to look at, I'm going to define with some neat pictures in the next slide. Reflections, translations, and rotations. Okay, here's the congruence transformations we're going to be talking about. Our first one is a reflection, or a flip, is a transformation over a line that we call the line of reflection. Okay, and each point on the pre-image and its image. So we could say here that triangle ABC is our pre-image and triangle FGH is our image. Every single point on the pre-image is the same distance from the line as the corresponding point on its image. Okay, remember when we talk about distance to a line, we're talking about perpendicular distance, right? So B is the same distance from this line as G is. A is the same distance from this line as F is. And C is the same distance from this line as point H is. Okay, if you have that condition, then you have a reflection. Okay, another type of congruence transformation is our translation, or a slide, where we simply kind of slide something over without twisting it or flipping it. Okay, so here's an example. We've got our pre-image triangle JKL and our image triangle MPQ. Okay, and when you have this case, every single point moves along the same, what we call vector. We'll talk about vectors more in chapter 8. But this, going from K to P, goes down and over the same amount as going from L to Q and J to M. They all slide on exactly the same vector. Okay, and our third type of transformation is a rotation, or a turn, where we're pivoting about a fixed point called our center of rotation. Let's pretend that we choose this as our center of rotation, and we have as our pre-image triangle RST. Then our image here is triangle WXY, and it's been rotated around this point right here. You can picture it like if you've ever played basketball and you drop your pivot foot and you can spin around on that pivot foot without traveling. Same idea. Okay, you can picture yourself pivoting around this center of rotation, and we end up with our congruence transformation. Here's our pre-image and here's our image. All right, here, could we identify the type of congruence transformation? Is it a reflection, a translation, or a rotation? Okay, going from our pre-image to our image, you can see it appears that this figure has simply been slid without being twisted or flipped, okay? And you can see that every single point appears to go down 2 over 5. We can check it here. This guy goes down 2 over 5 to get to its corresponding point in the image, and down 2 over 5. Okay, so that's our vector right there. And since every single one of these points is sliding along the same vector, we can say that that is a translation. All right, what type of congruence transformation is shown here? We've got this triangle as our pre-image, and here's our image. It appears that this triangle has been rotated about some center of rotation. In fact, it appears that the center of rotation is the origin, okay? And you'll see that every single point actually remains the same distance from the center of rotation. So here, we rotate it over here. This point ends up over here, and you can see as it rotates, it stays the same distance from the center of rotation. And likewise, this point here swings over to here and stays the same distance from the center of rotation. And you can check that. Remember, your distance formula tells you that distance from here to here is, I get a delta x of 1 and a delta y of 4. And to get from here to here, I've got a delta x of 4 and a delta y of 1. So I know this distance will be the same as that distance. All right, what's this guy? Reflection, translation, or rotation. We've got our pre-image here, and it appears that we have this irregular concave pentagon and its image down here, okay? It looks like a reflection, and we can confirm that if we identify the line of reflection. It looks like this is being reflected over what line? Looks like our x-axis is our line of reflection, and you'll notice that every single point on the pre-image is the same distance from the line of reflection as its corresponding point on the image. Okay, this guy is 1 unit above the x-axis, this guy's 1 unit below. This guy's 3 units above the x-axis. Its corresponding point on the image is 3 units below. Here, 2 units above, 2 units below. 1 unit above, 1 unit below. And 3 units above, 3 units below. So I would say that is a reflection over the x-axis. All right, how about this guy here? What type of congruence transformation are we talking about? If this is our pre-image and our image, it appears that this point corresponds to this point. Okay, so it looks like we slid over 4 units, and this point corresponds to this point. Also, just sliding over in the positive x direction 4 units, and the same here. Since all 3 of these points move along the same vector, I'm going to say that's a translation or a slide. We just slid this piece over there without twisting it or flipping it. How about this guy? What type of transformation do we have here? We've got our pre-image triangle and our image, and it looks like this has been mirrored. It looks like it's been flipped. And what's our line of reflection? Looks like our line of reflection is the y-axis. Can we confirm this? This point is 1 unit from the y-axis. Its corresponding point on the image is 1 unit. Okay, so we go here from 4 units to the left of the line of reflection to 4 units to the right of the line of reflection. And the same here, 4 units to the left, 4 units to the right. So I would say this is a reflection. How about this guy? What type of transformation do we have here? Reflection, translation, or rotation? It would appear that our blue pre-image and our image, it looks like what we've done is we've rotated about some point. Okay, I actually think our center of rotation is our origin. Okay, and we could confirm that. This point looks like it ends up over here. Okay, so it's the same, notice it's the same distance from the center of rotation, right? I got a delta x and a delta y of 1. Here I got a delta x and a delta y of 1. So that point ends up over there. This point here ends up right there. And let's just check that. This is 3 units over and 1 unit up. So we have a delta x of 3 and a delta y of 1. Here I've got a delta y of 3 and a delta x of 1. So that point is the same distance from the center of rotation. And likewise here, I've got a delta y of 3 and a delta x of 3 and a delta y of 5 to get here. And that point swings all the way over here, where I have a delta x of 5 and a delta y of 3. So that point ends up here, and this point ends up here. You can see I've got a delta x of 1, delta y of 5. Here I've got a delta x of 5 and a delta y of 1. So this looks like a rotation about the origin. All right, in this problem, they want us to do the hard work, okay? They're telling us that triangle PQR has these vertices, and it's a transformation of triangle JKL with these vertices. Could we graph the original figure and its image, identify the transformation, and verify that it is a congruence transformation? Okay, so they're saying that triangle PQR is a transformation of triangle JKL. So let's start with our original triangle JKL. J is at -2, 0. Okay, here's J. -2, 0. Point K is at -3, 5. So, or -3, -5, excuse me. So over 3, down 5, 1, 2, 3, 4, 5. Here's K. Okay, so K is at -3, -5. Good. And L is at -1, -4. So that would put us right there. L, -1, -4. Good. All right, I'm going to go ahead and, since it's a triangle, I'm going to draw those sides. Okay, there's one side, another side, and side KL. Okay, that all looks pretty good. Triangle PQR has vertices 4, 2, so I'm going to go over 4 up 2. Okay, so there's P, 4, 2. Q is at 3, -3 over 3, and down 3. And so that's Q. Oops. Q is at 3, -3. And point R is at 5, -2. So I'm going to go over 5 down 2. Here's R. 5, -2. Good. Okay. This looks like a congruence transformation. What type do we suspect it is? It appears that this triangle has not been twisted, has not been rotated, has not been flipped. It appears that it has just been slid from here to here. So it looks like a translation. How could we confirm that it's a translation? You could do that little vector trick that I showed you. Okay, if you want, what you can do is you can do the distance formula 6 times and say, okay, this side's congruent to that side, this side's congruent to that side, this side's congruent to that side. You can do that, and that's fine. And that might be pretty easy to pick up. If you remember one of our prior lessons, we said if you confirm that you've got the same delta y and delta x for this side as you do for this side, same delta y and delta x, up 5 over 1, then you can say this side is congruent to this side. Okay, and we do the same thing here. We can say I go over 2 up 1, over 2 up 1. They've got the same delta x and delta y, so these two segments must be congruent as well. And then the same thing here. I got a delta x of 1 and a delta y of 4, delta x of 1, delta y of 4. Since they have the same components that are going to go into your distance formula, you don't even need to do the distance formula. You don't need to actually run it out. Another thing you could do is you could say, hold on, how about our vectors? To go from J to P, I go over 1, 2, 3, 4, 5, 6, and up 2. Okay, so this has a vector. We'll talk more about vectors in chapter 8, but you'd give this vector, give it a component form. You'd say, what did I say, 6? 1, 2, 3, 4, 5, over 6 up 2. Okay, does every vector here have that same component form to go from L to R? I go over 1, 2, 3, 4, 5, 6, and up 2. Good. And to go from K to Q, I go over 1, 2, 3, 4, 5, 6, and up 2. All of them have the same vector, and that's another way to confirm that this is a congruence transformation. But if you wanted to look at your distance formula and just prove all the sides congruent, you can use side, side, side to verify that this is a congruence transformation. All right, one last problem. Here's a good place to pause the video if you guys want to Excuse me, if you have some graph paper and you want to try one of these on your own. They give us triangle ABC with these vertices, and they say that that is a transformation of triangle XYZ with these vertices. Graph the original figure and its image, and then identify the transformation and verify that it is a congruence transformation. Okay, so triangle XYZ with vertices x equals -1, +4. Here's x, okay? I want 4, and I got y at -4, +1. So I'm going to go -4, +1. And z is at -1, 1. So here's z. Okay. I like this triangle. It's a right triangle. Right triangles are nice and easy to work with, especially when they plot like this. Okay, so there's triangle XYZ. That's our pre-image. And then let's see what happens. What kind of a transformation are we looking at when we go to triangle ABC, our image? A is at -1, oops, excuse me, -1, -4. Okay, so here's A. And B is at -4, -1. So -4, -1. There's B. Okay, and C is at -1, -1. Here's point C. Okay, all right, I'm starting to get a picture of what's going on here. It would appear to me that this is a reflection over the x-axis, right? It appears to be a reflection over the x-axis. How could we confirm this? Well, really quickly, we can get two pairs of sides congruent in both triangles. I can say this side's congruent to this side. This side's congruent to this side. And by the way, since this is the delta x and delta y for this side, we know these two sides must be congruent as well. The hypotenuses of these right triangles must be congruent as well. So we can tell that these are congruent. Another thing you can do is you can say, well, hold on, my line of reflection appears to be the x-axis. Okay, so this point is 1 unit above the line of reflection. This one's 1 below. 1 above, 1 below. 4 above, 4 below. And that confirms that it is in fact a reflection over the x-axis. Okay. All right, guys, I hope you found this lesson helpful. Thanks for watching, and let's tackle some of these problems when I see you in class.